Welcome to the lecture. Today we are going to see the problems on mesh analysis with AC sources. So here you may have AC voltage source or AC current source. In this case we can use any of the sources in the electric circuit. From that we can determine the current in each loops. Let us see the example. Using mesh analysis, find the loop current for the given circuit. In this given circuit, we'll have a AC voltage source which is connected at loop 1. So now we'll go for the solution. Step 1 in mesh analysis, identify number of loops. In this case, we'll have 3 loops. Step 2, assume the current direction in clockwise in each loop. Let I1 be the current in loop 1, I2 be the current in loop 2, I3 be the current in loop 3. So when we go for AC sources, instead of resistor, we can have a inductor and capacitor connected in each loop. So in this case, we can go for the normal mesh analysis. Step 1, apply KVL to loop 1. Now, so we have to check whether any voltage source connected at loop 1. Yes, in this loop 1 there is a voltage source. Now we have to check whether it is voltage rise or voltage drop. So the given voltage source and the assumed current direction are in same direction, so that the given voltage source is a voltage rise. So that we can write the equation as 100 at an angle 0 equal to 5I1 plus J5I1 plus 2 into I1 minus I2. Now simplify this equation, that is 5I1 plus J5I1 plus 2I1 minus 2I2. So we can simplify that. 7 plus J5 I1 by taking I1 common minus 2 I2. So we can rewrite this equation as 7 plus J5 I1 minus 2 I2 equal to 100. So 100 at an angle 0 is nothing but 100 plus J0. So simply we can write it as a 100. So take this as equation number 1. Now similarly apply KVL to loop 2. Apply KVL to loop 2. We have to check whether any voltage source connected in loop 2. So in this case, there is no voltage source connected in loop 2. So we have to take it as 0. Now apply KVL 0 equal to 2 into I2 minus I1. Here the 2 ohm resistor connected common between loop 1 and loop 2. Then we are taking loop 2 current as a major current, so that we are writing 2 into I2 minus I1 plus 4I2 minus J2 into I2 minus I3. In this case, minus J2 capacitive reactance, which is connected common between loop 2 and loop 3. So that we are writing minus J2 into I2 minus I3. Now we can simplify this equation as minus 2I1 plus 6 minus J2 I2 plus J2 I3. Now we can rewrite this as minus 2I1 plus 6 minus J2 I2 plus J2 I3 equal to 0. Take this as equation number Similarly, apply KVL for loop 3. Apply KVL to loop 3. Here also we have to check whether any voltage source connected in loop 3. So there is no voltage source is connected, so we can write it as 0. 0 equal to minus J2 into I3 minus I2 plus 4I3 plus 2I3. So J2 I2 plus 6 minus J2 I3. J2 I2 plus 6 minus J2 I3. So we can rewrite this equation 6 minus J2 into, sorry, J2 I2 plus 6 minus J2 into I3 equal to 0. Take this as equation number 3. Now we can solve this equation using Cramer's rule. So we have to write this equation in matrix form. So in matrix form, we can write Ax equal to B format. Ax equal to B. Here the x represents number of unknown currents. So in this case, here we will have a 3 equation with 3 unknowns. So we have to write 3 cross 3 matrix. Now for equation 1, we can write in matrix form 7 plus J5 minus 2, 0. And for second equation, minus 2, 6 minus J2, J2. And for third equation, 0, J2, 6 minus J2. The unknown current, we can write it as I1, I2, I3. That is equal to, we have to write the constant. The constant is 100, 0, 0. Now, we have to apply the Cramer's rule. By using Cramer's rule, we have to determine the current I1, I2, I3. So that we have to determine the value of delta. So delta is nothing but determinant of the matrix here. Now we have to determine the determinant for the matrix 7 plus J5 minus 2, 0. Minus 2, 6 minus J2, J2. 0, J2, 6 minus J2. Okay. Now we have to determine the determinant. So if you simplify that, 7 plus J5 into. So if you take the determinant as, by taking first row as a reference, this first column and first row will get cancelled. So that we can write multiply 6 minus J2 into 6 minus J2 minus J2 into J2. Then second coefficient plus 2 into, you have to remove the second column first row. So that it become minus 2 into 6 minus J2. And the third element become 0. Now in this case, if you simplify this first element, we can get 7 plus J5. So we have to do the complex multiplication in the calculator. So if you do the complex multiplication for this term, 6 minus J2 into 6 minus J2, it becomes 32 minus J2. 24 into minus, here J2 into J2 become minus 4. So minus into minus become plus 4 plus 2 into, just we multiply this minus 2 into 6 minus J2 minus 12 plus J4. Again we can simplify this, 7 plus J5 into 36 minus J24 minus, we can multiply this 2 into minus 12 plus J4, so it become minus 24 plus J8. Again we can do this complex multiplication for the first term. If you do the complex multiplication, we will get 372 plus J12. Now again we can add minus 24 plus J8. So if you simplify this value, we will get delta value. So delta equal to 348 plus J20. Now either we can use this delta value in rectangular form, or we can convert this rectangular form into polar form. So when we go for division, the conversion from rectangular form to polar form will be very easy. So then we can convert this rectangular form of delta value into polar form. If we convert this rectangular form into polar form, we will get 348.57 at an angle 3.289. So this is the polar form representation of the delta. Now we have to determine the values of I1, I2 and I3. So for that we have to determine delta 1 value, delta 2 value and delta 3 value. So now we can determine delta 1. So how we can determine the delta 1 value means, we can replace the coefficient B value in the first column of the matrix by replacing the first column with the coefficient, that is 100, 0, 0. Then we can keep the second column and third column as it is. So minus 2, 6 minus J2, J2, 0, J2, 6 minus J2. Now we can take the determinant value. So if we take the determinant value, we can take 100 into, we can eliminate the first column and the first row. Again it becomes 6 minus J2 into 6 minus J2 minus J2 into J2. Minus into minus become plus 2 into the second column and first row become cancel, and then the remaining part, if you multiply that also become 0. Now if you simplify this value, we will get delta 1 equal to 100 into, if you do the complex multiplication here, already we have done this complex multiplication for the delta calculation. So if you multiply the 6 minus J2 into 6 minus J2, again we will get 36 minus J24 minus J2 into J2, it become a minus 4. So we can take minus into minus plus 4. Now in this case, we can get delta 1 value as 100 into, sorry, here it is 32 minus J4, 32 minus J24 plus 4. So if you simplify that, we will get 36 minus J24. Now the delta 1 is equal to 3600 minus J 2400. Again we can convert this rectangular form of delta 1 value into polar form. So if you convert into polar form, we will get delta 1 is equal to 4326.67 at an angle minus 33.69. This is the polar form representation of delta 1. Similarly, we have to do the calculation for delta 2 and delta 3. So for delta 2, replace the B coefficients in the second column. So if we replace with the second column, there is no interchange in the first column. So we can write as it is. 7 plus j5 minus 2, 0. And the second column we are replacing with the coefficient. That is 100, 0, 0. And the third column we are keeping as it is. 0, j2, 6 minus j2. Now for this delta 2, again we have to take the determinant value. That is 7 plus j5 into, we are removing the column 1 and first column and first row. So first column element become 0 plus minus 100 into second column first row we are removing. So it become minus 2 into 6 minus j2 minus 0. So if you simplify this value, we will get minus 100 into minus 12 plus j4. So the delta 2 value become 1200 minus j400. If you convert this delta 2 value into polar form, we will get 1264.91 at an angle minus 18.43. Similarly, we have to calculate the delta 3 value. So for delta 3, we can replace the third column with the B coefficients by keeping column 1 and column 2 as it is. 7 plus j5 minus 2, 0. Minus 2, 6 minus j2, j2, 100, 0, 0. By taking the determinant value here, 7 plus j5 into, by removing first column and first row, first element become 0. First element become 0. So minus into minus become plus 2. By removing second column and first row, we will get the second element also 0. And the third element 100 into, by removing third column and the first row, it become minus 2 into j2 minus 0. So the delta 2 value is equal to 100 into minus j4. So delta 2 equal to minus j 400. If we convert this delta 2 value from rectangular form to polar form, it become 400 at an angle minus 90. Now we have determined all the values of delta, delta 1, delta 2 and sorry, here it is delta 3. We have determined all the values of delta 1, delta 2 and delta 3. Now we have determined the values of I1, I2, I3. So I1 is equal to delta 1 divided by delta. Now the value of delta 1 is 4326.67 at an angle minus 33.69 divided by the delta value is 348.57 at an angle 3.289. Now, so if you simplify this value, we will get I1 is equal to 12.41 at an angle minus 36.979 amps. So this is the value for I1. Similarly, the I2 equal to delta 2 by delta. I2 equal to delta 2 divided by delta. Delta 2 value is 1264.91 at an angle minus 18.43 divided by delta value is 348.57 at an angle 3.289. So if you simplify that, I2 become 3.629 at an angle minus 21.72 degree amps. So this is the value of I2 in polar form. Similarly for I3, delta 3 divided by delta. So delta 3 is 400 at an angle minus 90 degree and delta value is 348.57 at an angle 3.289. So I3 is equal to 1.147 at an angle minus 93.289 amps. So this is the way we are using mesh analysis for AC circuit also. Thank you.